In this video, we'll be talking about gas-fired heat exchanger calculations. So in this release of the MPP, we have included sensible coil calculations. So that would be strictly dry bulb temperatures for sensible energy. And we're able to calculate discharge air temperatures if we know capacity, or we're able to calculate water flow if we know capacity and the delta T. So this video will be talking about those equations. I would highly recommend that you guys are reading through the user manual because we have a lot of these equations summarized in there. And the fact that all of these families have been built from the mechanical equipment configurator, you should have very similar functionality from family to family, making it easy to understand once you learn it once. I have the quality control sheet open, and we talked about this in the previous video, but essentially this is a sheet that has a whole bunch of data that can be reviewed in the model. So one of the things is gas-fired heat exchanger calculations. I want to show you though where these schedules are located, which I didn't say in the previous video. So if we scroll down in our schedules, all of these are under M_design. So there's quite a few here. We just talked about airflow in components and airflow in equipment previously. So all of these design schedules are here to help you guys with these calculations and with the inputs and final values, and essentially getting your schedules filled out as quick as you can. So gas-fired heat exchanger calculations, let's talk about those. So yeah, this schedule right here ends up being this schedule right here, design gas-fired heat exchanger calculations. All right, so similarly with the other design schedules, gray values are calculated values that you shouldn't edit. Blue values are overrides or inputs. And then green values are some design values. So let's talk about the air side first. Let's talk about the rooftop unit. All right, we have these RTU families that now we want to do some calculations on. We have calculated airflows and we have input, and these airflows right now are being used in the gas-fired heat exchanger calculations. So if we look over here under air side, these flows essentially are being controlled by the fan airflow, which is being controlled by the supply airflow. So let's talk about, well, first let's talk about efficiencies. So we have a performance table right now based on Carrier rooftop units that has all of their gas loads and heat settings built into it. So a user can come in and check a box and choose what size burner they want. So before I start flexing these around, let's talk about some of these numbers. So the input right here is the load. So this, in the rooftop unit case, is coming from a performance table. However, these values are going to be editable, which is why this column is green. So input at minimum fire is a calculated value from the number of stages. So like this boiler here, if this was a 5-stage boiler, you'll see this value change and also this value change. So capacity and capacity at minimum fire come from the efficiency. So don't confuse this with an AFUE or even a thermal efficiency. This is a specific efficiency based upon your design that you can use to determine what these are. So for boilers, a lot of times that's dependent upon what your return water temperature design is. For the rooftop unit family, this is, once again, coming from a performance table. So I'm going to change this back to 15. All right, so now let's talk about some sensible coil calculations. Right now, we have entering air temperature as a user value that needs to be edited. In due time, I fully believe we'll be able to do mixed air calcs based upon return air temperature and outside air, and that outside air percentage. But right now, you would have to enter your entering air temperature. So essentially, we're able to calculate the leaving air temperature, discharge air temperature. So this is detailed right in the user manual, but this is the classic equation: 1.08 times CFM times delta T equals BTUs. So essentially that's what we have. We've preserved all data types within Revit, so there's no tricks with numbers. We have a air density parameter and an air specific heat parameter that we use to determine that 1.08. But here we are. We have a discharge air temperature of 106.6 degrees Fahrenheit. So just the same, if we wanted to change the heat setting on that, we could choose a lower heat option. And now we're at 83.6. So I guess in hindsight, I would probably end up at medium heat. So these sizes of burners is something specific for the rooftop unit family that's included in the mechanical productivity pack. In most cases, the families, like this one right here, I have the configurator on the top line here. Essentially, you would be specifying your BTU value. So you'd say this is 360 MBH, and you'd give it an efficiency. So maybe this is 80% efficient burner. We've got 2 stages. So right now at 5,000 CFM, we're at a leaving air temperature of 108.3. So this is a calculated value in the schedule. You can't edit this. To edit that, you would have to go and change your burner size. So on the water side too, this second line is a boiler. So we have a 750 MBH boiler. And for the boiler, we're going to have a design flow. So this is going to be a value that someone would edit. So we could say it's going to be 35 GPM. And now with our entering water temperature and leaving water temperature, we're doing the calculations the other way. Now we're calculating the load based upon the design flow. This value isn't used in the schedules. It's mainly used to help with design and help to show you how much load you have on your given boiler. So right now we have a capacity of 690 MBH, and we're at 494. So we've got a significant safety factor there. And then, as I mentioned, the AFUE and thermal and combustion efficiencies, a lot of times these end up being rated values. So we're not using these to drive the equations. We're using this other efficiency parameter that's specific to the gas-fired heat exchanger. And that is the gas-fired heat exchanger calculations. Once again, more of your schedule filled in with just a few inputs, and all you guys have to do is learn where to change those values. Thanks.